sort of the driver behind this is we have sites, we know we have contamination, we install a soil vapor extraction system, and that reduces that contamination, but the question is always, if we have some persistence in the source, what does that mean to us? And the issue with that is it's a transport question. The source is located in the vadosome, but what we typically care about is either the surface or the groundwater. So how do you make that connection and understand, all right, have I done enough to meet my cleanup goals? And so that's the kind of basic context for it, but I wanted to have Dave come up and kind of give a broader context for how he sees that at some of the sites he's been working at and how this tool kind of fits into helping support sites make decisions.
Certainly the remaining mass, or the mass in the vadosome, represents a threat, by a number of different exposures, right? You have the potential direct exposure for contaminant mass that's remaining in the vadosome. You have the potential, as Mike said, the potential impact to groundwater, either through leaching or vapor transport from that mass down to the groundwater. And then you also have the potential for vapor intrusion from either the source area or contaminant mass that's diffusing off the water table. Obviously, you have to have a solid conceptual site model in order to really most effectively address these kind of sources. And we're going to talk about the importance of conceptual models, on several levels here as we talk about SVE and pump and treat. So everything should be, sort of wrapped into your conceptual site model. Now, certainly soil vapor extraction is a means to address these different kinds of exposures, right? I mean, we can do mass recovery, we can prevent that mass flux to the groundwater, we can control the vapor intrusion. But during the life cycle of the implementation of any soil vapor extraction system, there are going to be a number of questions that come up at different times. So, some of the typical questions that I've certainly run into during the course of years of consulting with our districts and federal clients on SVE sites are these kind of things. So, first, we often have a site where an implemented soil vapor extraction remedy has been going on for quite a while. We've gotten a lot of mass out of the ground. We've seen tailing, the exponential decline to some kind of almost asymptote, and really want to know, can we turn this thing off? And there's a lot of different ways that we can evaluate, where we're at with the system. You probably dealt with these kind of sites. You have a standard, perhaps a soil concentration standard that you have to meet. You're going to collect data about your soil gas concentrations, the influent to the SVE system, soil gas concentrations in the soil vapor probes that you may have at the site. You may actually have a fairly, state-of-the-art kind of mass flux estimate, what kind of mass is being released by the remaining sources within the vadosome, and have some estimate of that. How can we use the soil concentration data, if we've taken some samples, or the soil vapor data or the mass flux data, how can we use those to evaluate whether or not we can turn our SVE system off? Another aspect, another question that comes up is, are there other technologies that we can either supplement SVE with or replace SVE with that would be more cost effective, more protective than the SVE system itself? A good example might be, well, you've gone on for quite a while at a petroleum site. Can we turn the system into a bioventing site instead of an SVE and more effectively deal with that source? Can we go to passive venting? Can we supplement the active extraction of vapors with some kind of chemical oxidation, gaseous chemical oxidation like ozone or something like that? So those are the kind of questions that might come up in an evaluation that you might periodically do at a site. If we kind of step back earlier into the life cycle, some of the questions may be, during your site characterization, we found something, do we really need to do something about it? Does it really pose a threat to groundwater or via vapor intrusion? Okay, what are the tools and logic that could be applied to help you answer that question? So we're going to talk about some things that will help you with those kind of questions. And then one of my most commonly encountered question is, what's an appropriate performance goal for a soil vapor extraction system? And this is, hopefully something you do before you implement the SVE, but a lot of times as you go on with the progress of the project, it may be that, well, the performance goals that we had maybe aren't quite so appropriate as we thought. Maybe there's a better way to set a performance goal in light of what we're seeing at the site. So we might, want to revisit that. Matter of fact, one of the case studies that we'll talk about is one where the performance goals were actually revisited based on what we were observing. So we'll get to that. But anyway, so these are the kinds of questions that often come up. And the logic that we'll be discussing, the tool that we'll be discussing, the SVEET tool as we call it, something that could really help you deal with some of these kind of questions.
We've produced a couple of different documents relative to this, and one of these you have, we printed out for you, is the Soil Vapor Extraction System Optimization Guide, and so that's primarily what we're going to focus on. There is a journal article that goes over a lot of the technical basis. That's Mark's paper, and he'll be talking about that here next to give you a synopsis of what that is about. And I do want to mention that there's also the soil vapor extraction guidance document that you have is really the one that's focused on the pathway to groundwater, but we recognize there's also the pathway for vapor intrusion. We have a companion tool called VETIS. The guts of those two are the same, so we're going to go over just the soil vapor extraction tool, but there is a resource here that you can go out to, and I think once we go through what we go through today, you can step into VETIS without a problem. In this top figure, during soil vapor extraction, you always have these zones that are going to be more persistent to releasing contaminants. And so they're going to be slower, and that's what causes some of the tailing that Dave was talking about. And so our question is, well, at some point, when can you stop extracting from the permeable portions, because the mass discharge from those persistent sources is going to be low enough to not be a risk issue. And so that's the question here in this bottom slide is, if we leave this zone of persistent contamination, where is it located, how strong is it, and importantly, what's its transport going to look like? And one of the things that we considered in developing this tool was that the tools that were out there, other than using a site-specific numerical model, didn't take into account effectively vapor phase transport. They did not look at that three-dimensional aspect of the system. And so that's what we really wanted to look at, both answering the question of when can you shut off SVE, or if you go to a site and you've characterized it, you can say, well, do I have enough mass discharge here and releases to need to do anything in the first place? And so the two tools that are related to this, one is called the SVEET tool, and it's a spreadsheet tool, and it's very easy to use, but behind it is a three-dimensional multi-phase numerical model. And so that's the power of this, is we've taken 1,000 simulations that we did for all sorts of different scenarios, and then we've collapsed that into a user interface that's just a spreadsheet tool. So that makes it very easy for you to use, makes it very easy for you to look at variations of parameters, but behind it is that more correct full transport of contaminants, which includes the vapor phase. And so this is just a screenshot, and you'll see this more later today. The companion tool I talked about, the VETIS tool, where these red squares are, those are basically exactly the same as the SVEET tool. Same guts behind it, same simulation behind it, but instead of providing a groundwater concentration, it provides you a gas phase concentration at a selected location. There are a couple differences we'll talk about as we go on, but basically the engine behind it is the same, so you'll know how that works. The stuff here in the middle is that we related that in this tool to the Johnson and Edgar, or an adaptation of the Johnson and Edgar model. So if you get a concentration beneath your building, you can use this tool to help estimate what the vapor intrusion can be into the building. We're not going to talk about that aspect because it's all in their paper, but at least this gets you from the source to the concentration beneath that building. So those are the two tools that came out of this.